Hi everyone, this is the ML Bull in part 4 of our series on using AI ML techniques in FX trading. This week we're going to explore the process of normalization. So if you remember or have watched the past videos, you'll know that our proposed methodology or our hypothesis of something in the previous 4 periods somehow predicts the price in 4 periods later. Has got some gaps. Basically what we're doing at the moment doesn't work, and one of the potential reasons for that is normalization. So this video we're going to go in and have a look at that. So firstly, a little on me. I'm the ML Bull, and I truly believe that machine learning can deliver some tangible return in FX trading, and I am a trader. I trade in foreign exchange for about 20 years or so. I've used traditional charting, statistical analytics, and more recently AI ML techniques. The disclaimer, of course, this is in no way financial advice. It doesn't advocate for any trading methodology, and merely trying to share some of the pitfalls I had to learn going through developing techniques that work for me. Obviously, you'll need to do your own. So let's get into it. Okay, so what we're looking at here is the AUD USD price over the last 7 years or so. You can see some pretty wild swings. The kind of floor here is around 0.55, and then you've got a ceiling just under probably 0.9, and that's a pretty wide gap. And if you're thinking about previous articles, you'll remember that in these systems, logistic regression, linear regression, and as we move into deeper learning and neural nets, you'll understand that there's a weight, a value times a feature, and what you get from that is this kind of static version of the system. So because it's a simple weight times a value, as the value moves, the weight becomes kind of irrelevant almost, and loses its ability to be accurate because it's tailored for the midpoint, the average. And so when your values move, it loses accuracy. And that's what the process of normalization is all about, trying to resolve. So if we were to plot 5 occasions that we saw the price increase that we're looking for, and if you remember, our hypothesis is something in the past 4 periods predicts the future, and we're measuring that as a 200-point increase in price. If we plot 5 random occasions, you can see the price variation, looking at the 0 point as the measurement of where we start, going back 4 periods, and then looking at the price 4 periods later. They're almost straight lines. And that's simply because the scales are so different that it just doesn't make sense. So we need a process to normalize that. We need a process to put them in the same scale so we can have a weight times the feature and give us a consistent set of outcomes. And we're clearly not getting that when it's like this. So let's replot this using point change. So from the value at the start of our historical period, the open price, and then the first period's the move to the close, and then for the Y period it's the value from the 0 line. So let's see what that looks like. So again, 5 random periods, and all of a sudden you can see that things have changed. Everything's now in the same scale. Everything works together, so when we apply a weight to the feature, it's going to look a bit more consistent. Those numbers are going to be far more valuable and make more sense. Does that illustrate any patterns? We do see these upticks in these 5 examples. This red line here was at July 04, that is going down, but the others going up. So maybe there's some type of pattern here. And remember, in machine learning, we're looking for patterns, and that's what we can copy and follow. That's essentially what we do in trading too. We look at what we've done before. There's a pattern we've seen before, and we can repeat that. So if we normalize this using points, it makes sense. But there are other techniques. So when we normalize, there's different ways we could do it. We just did it with points here, and points is useful because the market works using these, or pips more accurately, but we'll do that in another video. And we normally set our take profits and stop losses. We'll talk more about these market dynamics in the future one. But there are other techniques. We can look at percentage changes, which is probably closer to accurate. There's more statistical techniques, normalizing between 0 and 1, and using standard deviations. Which is better? Well, that's what we're going to have a look at. But points is often used. It's not as statistically preferred, but it makes everything readable. It's the language we talk in trading. So it kind of makes sense if we can do it, and if it works, to use that where we can. So does it work? And that's the question we have to follow, is create a bunch of code so we can test all of these techniques and see what it looks like. Okay, so in previous versions we've created a bunch of kind of linear code that runs through and works. This time around we're going to put everything in functions so that we can create an iterative approach. So we're not really adding a lot new to the work we've done previously, but we are making it more repeatable and more in functions. So if anyone is really familiar with Python and what we're doing, will be screaming use classes and so forth. Don't worry, we're going to get to that. We'll move to that. We're taking baby steps. So you can see here, this is a function that normalizes our data. It takes an input as a data frame and then a method. The price method is just use the price. That's kind of the default. And then we have method to change to use points. Notice if you're in the field of statically put a number to convert a 5-point FX price to points. That's not necessarily correct, but we're working with AUD USD exclusively, so it works in this scenario. But keep in the back of your mind, when we do move to other currencies, this won't necessarily work. And the code for percentages to use it as some function of an open price, and we've separated the open price for the historical feature data and the future data separately. So that's this X open and then the open price of 0.0 for the Y. And you can see we've created rather than just having a single Y point 4 periods in the future, we're going to create it for each one, because that lets us graph it and move forward from there. We use in the sklearn functions for min-max, which will normalize between 0 and 1 by default. You can set it to anything, but that's its default. And the standard def method uses the sklearn, and what you'll get from that is values typically between about -2 and 2, a bit more, 2.5, but depends on the value. So we'll try them all. Stuff we've seen before, doing the class weights is now made into a function here, and then this display thing. So if we display some debug value, and when you're debugging, it's good to have this stuff. And then when you run it in production, you generally turn that off once you know you've got your accuracy and the code works as you expect. Training and validation data sets, no real change. The metrics hasn't changed. You should note next video we're going to change this quite a bit, because this isn't quite what we want, but I'll explain that next video. And then this function to chart everything and make it look the way we want. This is new, but this is not rocket science. This is just some nice way of doing charts so we can see what happens. And then the load data, we've now combined the load data with creating the historical and future prices in one, as well as the standard measurement of what our Y values are. And then we simply run into a loop through each normalization method, load data, normalize it, get out Valentine data sets, and then plot it. Okay, well, sorry, normalize it, class weights, train it, and then get the metrics and plot it. And I've done the plot, so you can see it here. There's a nice little tag here with giving us what our results are. So, you know, when we run this, you can see, looking at the price, we've made these 5 events the same through each method, so we can be consistent about what the graphs look like. So what's going on? And you can see the differences here. The price, the standard one we saw before in the middle, percentage and points, not surprising, look very, very similar. And the standard deviation and min-max techniques look very similar, but the numbers are a little bit different. Normalized between 0 and 1, and normalized between kind of about -1 and 2-ish. So you can see the differences. Certainly the percentages and the points look far more standardized than any of the other techniques. But if you look at the training loss, the true positives, the false positives, precision, etc., it really hasn't made much difference using normalization. And that flies in the face of pretty much all the theory around it. So there's 2 real possibilities. The first is that the theory's wrong. Every academic in the space has got it completely wrong, and no one knows what they're talking about. That's theory 1. Or theory 2, there's something more fundamentally wrong with our hypothesis. And our hypothesis was that something in the last 4 periods predict the next 4. And that is starting to look unlikely, and certainly a far more likely conclusion than the entire field has got it wrong. So why is that? So our summary here is really, it's likely that our hypothesis that something in the past 4 periods predicts the future may not be correct, or may not have a lot of correlation between the 2. Which is a hypothesis we haven't yet proven. It was an assumption we make. And this is a pretty normal process in FX. Hypothesis, test it, does it work, yes or no? All right, move on. All right, what's your next hypothesis? And you're going to do this a lot. This is going to happen a lot. We could apply different FX techniques and machine learning techniques, but I've done all that, and I assure you, in this scenario, it's really not going to make much difference. Instead, there's something more fundamental about our correlatory assumption between the past and the future. And that's what we're going to move on to in the next episode, is looking at how we can augment our features to make it more correlatory into the future, and what some of those features are. And we're going to focus on that and try and create some correlation between the past and the future in the next couple of episodes.